All right, did anybody arrive at the answer? Can somebody share what they get with me? All right, let's.
0.875, sir.
What's the answer coming?
0.875.
0.875.
875. I got that as well, sir.
All right, 0.8, and nobody, and everybody work it with the procedure that you learned just now, right?
Yes, sir. I did it.
Yes, sir.
Okay. All right, so let's just see what happened. So 0.875, that's what everybody gets?
Yes, sir.
All right. All right, so this is it. So actually, everybody should know how to carry out the algorithm, but let me walk through it and give you an explanation of what is really happening when you do that, all right? Now, remember now, decimals are special fractions. So if you don't have any whole number, we generally insert a 0 in front of the point. So the 0 here would tell you that you don't have any whole number. All right, now when we are dividing, if it's similar to when we are dealing with mixed number, right? If you have a mixed number, let's say that we have 9/8, and this would be an improper fraction. If we are to convert this to a mixed number, generally what would we do? Anybody?
Cross multiply.
Hmm?
Will you cross multiply?
No. You're converting it to a mixed number now.
Divide 9 by 8, sir.
You divide the numerator by the denominator. So what you say is 8 divided into 9. Give you how many times?
One time I want for 8.
So you can get 8 out of 9 one time. So that one becomes the whole number. And the remainder will become the fractional part. So 1 and 1 over 8. All right, everybody see that? Is this
Yes, sir.
is the same principle that we are working with when we are converting to decimal. So if we were to convert this into decimal, can anybody tell us what we would get? Let us try to convert this into decimal. So we would have the division bar. We would put inside here, we would put the numerator under the bar, which is 9. And then we put the denominator outside. So we'd say 8 into 9 goes what? 1 times. And then it would be one whole number. Then we say 8, 1, 8, and we take away 8 from 9. We get what? We would have 1, right?
Yeah.
So now what we're going to say next, 8 into 1. Can we get 8 out of 1?
No, sir.
No. So this part now becomes a fractional part. So because we cannot get any more whole number out of the number that remains, then what we have to do now is we put a point because we already got the whole number part. And now what we're going to do, remember that we say anything that comes after the point going to be over powers of 10. Everybody remember that? So this one now, in order to make it out of over 10, that means we would have to multiply this by a 10. So when you multiply it by a 10, you just add a 0. So now we say 8 into 10. And 8 into 10 now, we would get what? How many times did we get 8 out of 10?
1, 1.
So we would have 1. And so we say 1 times 8 give you
8.
8. And now we would subtract 8 from 10, we get what?
2.
2. Now we're going to say 8 into 2. We can't, so we have to go to the next power of 10. So we have to multiply it by 10 again. So now this is times 10 again, which is simply just adding a 0. And then we say 8 into 20 now goes how many times?
4.
5 times.
8 into
5.
20 goes
2 times.
2
2.
times. So 2, 8 give you
16, yes.
and
Mhm.
remainder would be what? 4.
4.
Now, can we get 8 out of 4?
No.
No, so we
No.
a 0. And then we say 8 into 40 goes
5.
5 times.
5 times.
How many times did we add 0 while we are dividing on this side?
3.
We add 1 0 here, 1 0 here, and 1 0 here. So what we're really doing is multiplying the denominator by 10 each time. So that's how we get these positions. So the first time we multiply by 10, we get the 10th position. The next time, when we add a 0, we get the 100th position. And the third time, we get the 1000th position. Is that clear to everybody? So
Yes, sir.
Yes, sir.
Sure.
let us go back to this one now. All right. So if we are, let me kind of put this to the side. So when we are really converting to decimal, we're really trying to follow the same principle as when you're converting what we call an improper fraction to a mixed number or mixed fraction. So this now we would put here, what would we put under here? We put the numerator. Outside there, we put the denominator. Now, remember now, when we were looking at fraction, the denominator tells us the total whole that the fraction is cut up into. Everybody remember that? So it means that if you can get 8 out of a number, that means you get, if you get it 1 time, that means you get 1 whole. If you get it 2 times, you get 2 whole and so on. Now the question is, can we get 8 out of 7?
No.
No.
That means we don't get any whole. So that means that the whole number part must be represented with 0. Now see that we did not get a whole out of the 7. To put a point, because next we're going to go now to the decimal fraction. Now to get this position, now we have to add a 0 to this. Now we are going to say 8 into 70 goes how many times?
8.
Huh? 8
Not
times.
hearing you clearly.
8.
8
8.
into 70 goes 8 times.
8 times.
Now we're going to say now, because every time you put a number up here, you need to multiply it by the denominator and subtract what you get. So 8 give you,
64.
64.
and then now we subtract 64 from 70. So that
And 6.
leaves us with what?
6.
6. Now we say 8 into 6. Can we get 8 out of 6?
No, sir.
So it means that we have to go to the next powers of 10 position. So that's why we're going to add a 0 here. And now we say 8 into 60 goes how many times?
7.
7 times. So 7 times 8 give you what?
56.
56.
All right. So now we're going to subtract 56 from 60. And then we get what?
4.
4. And then now can 8 go into 4?
No,
No,
sir.
sir.
No, so we have to get the next 10th position. So we times it by another 10. So that's in now the 1,000 position. So we have 8 into 40 goes what?
5.
5 times.
So we now have 5, and then we use that 5 to multiply by the 8, and we get 40. Now, the moment we have just zeros below, we know that the division would have ended and the conversion would have been this value up here. So this would be the decimal equivalent to 7/8. Everybody get that, right? And
Yes, sir.
now, is everybody now comfortable with this conversion? Raise your hand. Okay, is there anyone who is not so comfortable and you want to see what was done? Raise your hand. Mr. Paisley, your hand is still up. So that you're not comfortable. Okay. All right, so let me see in the chat. Okay, all right, so Mr. Arthur said that he joined a little late and he never really got the first part. We're doing here, Mr. Arthur, is we're actually converting fractions to decimals, and just in the same approach that Ms. Wasom was given is the same approach, but I was just explaining to them, to the students, or to everybody, what happened, why we actually add a 0 each time. Okay, back through this one, just to get you to see what is happening. Are you there, Mr. Arthur? So we say when we're converting fractions to decimal, we put the numerator under the division sign, the division bar, and the denominator outside in the brackets. We divide in the usual way along the division, but when we try to divide by 8, when we say 8 into 7, we notice that we cannot get 8 out of 7. So in the fractional sense, when you can get the denominator out of the numerator, if you get it 1 time, then you have 1 whole number. If you get it 2 times, you have 2 whole number, and so on. In this case, we cannot get 8 out of 7. It means that we don't have any whole number. And because we are converting this to decimal, we know that the whole number part would be inserted in front the point. So if you have 8 into 7, you can't. That means you have 0 whole number. So you put down 0, and that would have accounted for the whole number section in the decimal. Now we need to now look at the fractional section. So we put a point. And then now after we put the point, we are now going to now look at the 10th position that come after the point. In order to work with that 10th position, we have to add a 0 down here. Now, when we really add a 0, it's not just adding the 0, no. We are actually multiplying by 10. 7 times 10 gives you 70. That means we are putting this over the 10th position, so we multiply it by 10. Now we say 8 into 70 goes how many times, Mr. Arthurs? All right, maybe somebody could tell us. 8 into 70 goes?
8 times. 8 times.
8 times. So we multiply the 8 times 8, we get 64. Subtract 64 from 70. We have remaining 6. Now that we finish with this 10th column, we need to go to the next column, which is the 100 column. So now we would have to multiply by 10 again to get to the next column, which is the next place value to the right. So we multiply by 10, and that's how we add the 0. Because 6 times 10 gives us 60. And then we say 8 into 60 now goes 7 times. And then now we do the same thing. Take the 7 times the 8, we get 56. Subtract. So each time we are subtracting, so we get now remainder 4. Now we're going to do the same thing again. 8 into 4, we can't. So we have to think about now adding a 0 because we're going to the next column. So it means that we multiply by 10 again. So now we get 40. Now we say 8 into 40 goes 5 times. And so we have 5, 8, 40. And here now, when we subtract, we get 0 down here. The moment you have 0 in the last row, you know that we are through dividing. And whatever you have on top of the bar now will become the equivalent to this fraction 7/8. So 7/8 is the same in the decimal form, would be just equal to 0.875. Is that clear now, Mr. Authors? Can you just give us a type in the chat and so that we can hear you? Okay, all right, good. So, all right, moving on. Let us see the general procedure when we are converting. So here, the general procedure is that you divide the numerator by the denominator. And so if we follow this procedure with 4/5, if you divide 4 by 5, we see that we can get 5 out of 4. So there's no whole number. So we put down 0, put a dot, and then now we would add 0 to the 4, and then 5 into 4 give it 5 into 40, don't give it 8 times, and that would be the answer. So everybody should be clear on this. All right, next we're going to be looking at rounding off. All right, now let me see the hands of those who actually are familiar with what rounding off is.
Me.
All right, now I'm going to ask the question. What is the purpose of rounding off? Anybody? Go ahead, Mr. Ojena. Why do we round off numbers? Mr. Ojena?
The engineers 10 or 100, sir, 1,000.
Nearest 10 or 1,000. All right, maybe we want to reach the nearest 10 or 1,000, but why? Go ahead, Miss. Go ahead. What, Miss Shay?
Sir, it's I learned that it's a easier way of simplifying numbers so that we can understand, and it can be exact sometime or approximate.
All right, so it will probably work down into some kind of approximation. Miss Waysam?
Yes, sir. No, sir. God, let me just double check. It gives us, sir, a better estimate and keeping the number close to its original value, sir. All
right. Yeah, those are quite good answers. So Miss Waysam, so good answers, guys. So generally as Ms. Wilson said, it keeps the number close to the actual value. And so later on, you will hear we talk about significant figures. Miss Michelle, you can lower your hand now. So when we talk about significant figures, we really mean what figures are really meaningful in your answer. All right. So rounding off help us to either have a good estimate of what the answer is, and it also helps to tell which figures are significant. And also it helps to give you a concise or a shortened form of what the number would actually be, because sometimes you may have a string of decimal places that comes after the point. And so you may not need to have all of that bunch of figures after the point. You just need to have closest to the one that is more meaningful to your value. All right, so that's the purpose of rounding off. Now, can anybody give me the procedure of rounding off?
So when greater than 5, you add 1, and
But less than that,
less than
you
5,
leave it.
it remains the same.
Okay. When greater than 5, you add 1. When less than 5, it remains the same. All right. Even though I know what you're saying, how it is explained is still a little bit vague. So there is still not clarity why that procedure is followed. Can anybody shine any more light on it for me? Why do we add 1 when it is 5 or more? And why do we subtract 1? Not subtract. Why do we allow the value to remain the same if it is 1 or less? Sorry, less than 1. I should say less than 5. Anybody? All right, so first and foremost, in rounding off, we need first to determine what value we're rounding to. So based on what value is more meaningful to our answer, we'll decide what value to round to. Now, rounding off, depending on the number that comes after the value rounding off to. So I just giving a little example. Suppose I have 3.435. And I say, all right, what is most meaningful for me is 1 decimal place. So I don't need to have any digits more than 1 decimal place. What is it that I do from here now? Who want to walk me through the steps? Or should I call on someone? Mr. Campbell, do you have anything to add?
No, sir, not this time.
All right.
Sorry.
All right, Miss Waysome. Anything to add? All right. Miss, all right, go ahead, Miss Cumming.
Okay, sir. So you want the to be at one
Please, yes.
decimal place? Okay, so you will focus on the three that is in the hundredth place, sir. So if it's five or more, then you will add one to the four, but if it's five or less, it will remain the same. So in this case, it is three, so it will just remain at 3.4.
All right. Now, so my question to you though, why do we add one and or why not adding one? What is the rationale behind that? And I'm going to just now having you round it off to the second decimal place. Go ahead, Miss Cumming. Are you there, Miss Cummings? Can you round this off to the second decimal place and explain?
Yes, sir.
Okay.
So wouldn't it be 3.44 since it's 5?
This would be what?
3.44 since it's 5.
All
So we're
right.
gonna add one.
So
3.44.
3.44. All right. Anybody else agree with this? Let me see the hands of those who are in agreement with this. 3.44 if you're rounding off to that. All right, yes. So the answer is 3.44. That would be correct. But why do we add one?
Because it's equal to 5.
Would it be because it's actually in the 10th place? Looking at it.
Is it because it is in the 10th place?
Yes, sir.
It doesn't necessarily have to be in the 10th place, you know.
Oh.
All right.
Because it's behind the point. Oh, sure.
If it is behind the point, well,
Yeah, because it's to the nearest 10.
It is to the nearest 10. Yes, but not quite what I'm expecting. All right, so really and truly what's happening here is that this number 5 here would tell you how close you are to the 3 or to the next number, which is the 4. So how close would you be to the 3 or the 4? Now, if you have, remember we're using a decimal. So if you have less, you think about the number close to 3 would either be 4, right? But if you have on a number line, right? And let's say that the 3 is here and the 4 is here.
Now go check. So sit down there, big head.
Now, if you have the next number that follows would be in this would be the hundredth column, but this would be in the thousand column. Now, this is a smaller fraction than this, but what we are saying, in order to be able to add 1 to this 3, you would have to, when we're counting, if you count, go right up to 10, we would add 1 to the 3. Now, we are saying that if it is 5, we are going to assume that we can say that we can round it up to 4, because we are saying once you have half or more, you are closer to the 4. If you have less than 5, then you would be closer to the 3. So if you have, say, 2, which of these value 2 will be closest to? 2 will be closer to 3. If you have 6, which value is closer to? 4. So we conclude that if it is 5 or more, we're going to round it up to the next number because it is more closer to that number, right? So in other words, if you have 3.5, we are going to call the half a whole and just add 1 to the 3, so we get 4. Is that clear, guys? Everybody understand what I just explained? Raise your hand.
Yes,
Can
sir.
you go over again, please?
Over, sir. Come in and understand.
All right, so we are saying that this digit here, this digit 5 here, we're saying that it is half of 1, half of a whole. And if it is less than 5, it would be it would be closer to 3. So in other words, if you call this 3.5, this is 3.5 here, this is where the 5 is. So 3.5, then 4. Remember, in order to get this to be 4, you would have to count this up to 10. So if you're counting and this was 10, you would add 1 to this and then you get 4. You see what I'm saying, Miss Waysom?
Yes, sir.
Right. So, but on the number line, this 5 here would be a fraction of a whole. So if you have the 3 here and the 4 here, this 5 here falling in the next position would be a fraction of this 3, which is in the 100 position. So we are saying that this is the same as, all right, think of it this way. This 3 is out of what? Out of what? 3 out of what?
10, sir.
No, man, 3 over 100, right?
Oh, yes, 100, sorry.
Right. And this 5 is over what?
10.
No, that will be out of 1,000.
What?
So we are saying that if you compare the two fractions, this fraction here would be comparison to this. Would we say this would be half of one of this whole? All right. So
Yes.
why we round up, because we are saying for these numbers, if you have a value between number line, if 5 was in terms of the number line and you share this into 1,000, so let's say this is a 3 and this is 4 and this is cut up into 1,000 parts. All right, so in comparison to this, because this is in the hundreds, we could actually say that this digit is next. This one is 10 times this one, right? So if you multiply this by 10 down in the denominator, you would actually see that this, to get it into 1,000, you'd have to multiply this by 10 to get the next denominator. But what we are saying that this 5 here would be considered as being half of this fraction here. If you think of it in terms of, say, a half, if it is 5, it would be closer to being, if you are to get 10. All right, if this was 10, what would happen here? You would cancel out one of this, right? And this one now, the two of them have the same denominator, so you could add them to get what? 4. You follow what I'm saying?
Yes, sir.
Right. But if it is less than if it is less than 5, is less than 5, then let's say 4. Then 4 would be closer to a number which is smaller than 1. So we wouldn't add 1 to the 3. So the lesser the numerator is the more, because when it goes to 10, it is close to 1. But when it goes less than 5, we are saying that it is closer to 0. So when it is 5, halfway, we can say that halfway, we take halfway to be closer to 10. But less than 5, we say it's closer to 0. So what number is closer to 0? We don't call it a full whole, but once it is 5 or more, we call it a whole. So if this becomes 10, as I showed you, this 0 cancels out, it becomes 1. And so we can add this 1 to the 3. Now we get what? This over 100. You follow?
Yes, sir.
Yes, sir.
Following what I'm saying? So that is the reason behind it, is that if the number that follows is 5 or more, it means that it is closer to 1 in the column that you're rounding off to.